Good morning guys. Today in our video I want to explain the chapter waves which is from second year. So here the JEE 2002 to 2010 questions are explained. So it is very important chapter for both JEE and NEET. So please listen carefully and practice as follows. So here before that all of you should subscribe my channel, like, comment and share to your friends. So let us start our topic. The length of a string tied to two rigid supports is 40 centimeter. Maximum length of a stationary wave produced on it is. So maximum length of a stationary wave, it is nothing but maximum wavelength. So here a string will be having between the two rigid supports it will be tied. So then for the first loop it will be in this form. So L is equal, it is 40 centimeter, which is nothing but L it is equal lambda by 2, the distance between two node points. So here, whereas L it is equal lambda by 2 it is equal 40 centimeter. So now we have to find out the lambda value. So because of the stationary wave produced on it, the length of the stationary wave, that is nothing but lambda, it will be 2 into 40, it is equal 80 centimeter. So lambda it is equal 80 centimeter. So whereas it can be the option B is right answer. Coming to the second question. Tube A has both ends open while tube B has one end closed. Otherwise they are identical. The ratio of fundamental frequency of tube A and tube B. So for taking tube A has both ends open. So this is the tube A having open at both ends. So then the first loop should be in this pattern. So then similarly tube B. So this is the tube B having one end closed. So then the first loop will be forms in this manner. So here the length of the an open pipe have nothing but tube A, that is lambda by 2, and it is L it is equal, so here it is nothing but lambda by 4. So here the frequency it is equal to N is equal to V by 4L, and here the frequency N it is equal to V by 2L. So here simply we can write for tube A the ratio between the fundamental frequencies of tube A and B. So tube A it is open pipe, so that is frequency of open pipe NO it is equal to V by 2L by, whereas NC it is nothing but closed pipe, it is equal to 4L by V, NO by NC. So then VV will be cancelled, LL will be cancelled, 4 by 2 it is nothing but 2 by 1. So therefore NO by NC it is equal 2 by 1, it is equal 2 is to 1. So the fundamental ratio of the frequencies of tube A and B it is, whereas 2 is to 1, option C is right answer. For the next question, the displacement y of a particle in a medium can be expressed as y is equal to 10 power minus 6 sin 100t plus 20x plus 5 by 4 meter, where t is in second and x is in meter. The speed of the wave is, so this is the general equation for the wave formation. So that should be compared to the, so y is equal to a sin omega t minus kx plus 5 by 4. So this is the general wave equation. So here the speed of the wave v it is equal to omega by k. So comparatively, so what the equation was given to us, so that is y is equal to 10 power minus 6 sin, whereas 100t plus 20x plus 5 by 4. So here, whereas omega is equal, here 100, omega is equal 100, and k is equal 20, k is equal 20, then the speed of the wave v is equal to omega by k, it will be written as 100 by 20, it is equal 5, whereas speed it is equal meter per second. So here 5 meter per second it is the right answer. Here the next question, When two tuning forks are sounded simultaneously, 4 beats per second are heard. Now, some tape is attached on the prong of the fork too. When tuning forks are sounded again, 6 beats per second are heard. If the frequency of the fork 1 is 200 Hz, then what was the original frequency of the fork 2? So here, if two forks at first beated to each other, so then the beat frequency or beats per second, it is 4, and after some time some tape will be attached. So if the tape will be attached, then the frequency will be increases. So then 4 to 6 it is right. So but now here what they are asking, it is the fundamental frequency of the if the frequency of the fork 1 it is 200 Hz, so and what was the original frequency of the fork 2? So here the frequency, the beat frequency delta n, it is equal to n1 minus n2. So here n1 was given that it is 200 Hz. What is n2? So delta n, it is the 4 beats per second. So delta n is equal 4 and n1 it is equal 200 Hz, and what is how much? N2 is how much? So here n2 is equal to n1 minus delta n. So n1 it is equal to 200 and delta n it is equal, which is 4, it is 196 Hz. So n2 is equal to 196 Hz. So that is here option D is the right answer. So here the next question, which was asked in 2003, the displacement y of a wave traveling in the x direction is given by y is equal to 10 power 4 minus 4 sine 600t plus 2x plus 5 by 3 meters, where x is expressed in meters and t is seconds. The speed of the wave motion in meter per second it is. So here the question is same as well as the question which was asked in 2004. So already we have done. So here we have to compare the general equation of the wave formation. So that is where omega it is equal, that is nothing but 600, and whereas k it is equal to, so here the speed of the wave v it is equal omega by k, it should be written as 600 by 2, it is 300, whereas meter per second, so it is 300 meter per second. So this is the right answer. So here the next question, a metal wire of linear mass density of 9.8 gram per meter is stretched with a tension of 10 kilogram weight between two rigid supports 1 meter apart. The wire passes at its middle point between the poles of a permanent magnet, and its vibrates in resonance when carrying an alternating current of frequency n. The frequency n of the alternating source is. So here if a wire will be stretched between two rigid supports, so here the first string it should be in the form of in this manner. So whereas the frequency of the n it is equal to 1 by 2l under root of t by m. So this is the stretched string to put t by m or t by mu. So here what are the components given that? So where it is T is equal tension in the string, that is T is equal to mg, whereas mass into acceleration, gram weight, g is equal to acceleration to gravity, and here 2l, L it is the length of the wire, that is given that 1 meter, and mu it is the linear mass density which was 9.8 gram per meter. So it will be converted into kilogram, 9.8 into 10 power minus 3. So just simplify that, we have to find the frequency of the accelerating current in the alternating current in the source. So here T is equal to mg, so that is nothing but mass into mass, it is nothing but 10 kilogram weight, 10 into g it is equal 9.8. Similarly mu it is equal linear mass density, that is 9.8 gram per meter, it is nothing but 9.8 into 10 power minus 3 kilogram per meter. So here L it is equal to 1 meter, a part of it. So there we have to substitute all those values. It is 1 by 2 into L nothing but 1. It is under root of T. It is equal to 10 into 9.8 by mu nothing but 9.8 into 10 power minus 3. So here 9.8 cancel out. It is 10 power minus 4. 1 by 2 into 10 power 4. So it should be 10 square. It is 1 by 2 into 10 square. It is 100. It is 100 by 2 nothing but 50. So 50 hertz. So 50 hertz, it is the frequency of the alternating source in a string. Here the next question is, an observer moves towards a stationary source of sound with a velocity 1/5 of the velocity of sound. So what is the percentage increase in the apparent frequency? So here whenever we have to see an observer moves towards a stationary source, then frequency will be increases. Already we know that the sound velocity 1/5 of the velocity of the sound. So here the observer velocity VO, it is equal 1/5 of the velocity of the sound. So here, so whenever observer moves towards the stationary source, then the apparent frequency n dash, it is equal n into V plus VO by V. So here VO is the observer sound velocity, it is V by 5, 1/5 of the velocity of the sound. So here we have to substitute the values. Then n dash, it is equal n into, whereas V plus V by 5, V by 5V. So here n into 6V by 5V, it is equal to n dash. So n dash by n is equal 6 by 5. So here n dash, it is equal 6, n is equal 5. The percentage of the apparent frequency, percentage increase in the apparent frequency, the percentage increase, it is equal change in the frequency n dash minus n by n into 100, percentage for 100. So here it is n dash, it is nothing but 6, n it is nothing but 5 by 5 into 100, whereas 1 by 5 into 100, it is equal 20. So whereas here the next question, it is, a string is stretched between fixed points separated by 75 cm. It is observed to have resonant frequencies of 420 Hz and 315 Hz. There are no other resonant frequencies between these two. Then the lowest resonant frequency for this string is. So here there is a string having the length that is 75 cm. So it is not at all a matter. And here the first frequency, the first resonant frequency, that is n1, it is equal 315 Hz, and n2, it is equal 420 Hz. So here we have to find out then the lowest resonant frequency for this string. Here the first resonating length n into V by 2L, it is equal 315 Hz, because of string has separated between 2 points in a 75 cm. So then the frequency, it is equal n into V by 2L is equal 315 Hz. The second resonating, that is n plus 1 into V by 2L, it is equal 420 Hz. So now we have to find out where 2 by 1. So n plus 1 by n into V by 2L into 2L by V. So here we have to do 2 by 1. It is equal 420 by 315. So here we can write down n plus 1 by n, it is equal, whereas 3 into 105. It is 4 into 105. 4 by 3. Here n is equal to 3 because of, whereas n is equal to 3, 3 plus 1 is equal to 4. Then n plus 1 is equal to 4. So if n is equal to 3, then we can write that n into v by 2l is equal to 315, whereas v by 2l is equal to 315 by 3, it is equal to 105. So n into v by 2l is equal to 315, v by 2l is equal to 315 by 3 is equal to 105. So this is the, whereas in case of, if n is equal to 1, that is the lowest value, n is equal to 1, it can be 1 into v by 2l. 1 into v by 2l is equal to 105. If n is equal to 3, then it can be 3 into 105, that is nothing but 315. If n is equal to 4, n plus 1, that is n is equal to 4, then 4 into 105. So 4 into v by 12 is equal to 105, then we can get 420. So the lowest resonant frequency, that is where n is equal to 1, how much value it is? 105 hertz. So this is the right answer, where option A. Here the last question, it is simple question. 3 sound waves of equal amplitudes have frequencies nu minus 1, nu plus 1. They superpose to give beats. The number of beats produced per second will be. So here the number of beats produced, it is n1 minus n2 is equal to delta n. So whereas n1 is the highest frequency and n2 is the lowest frequency. So here the nu plus 1, it is the highest frequency, whereas n1 it is equal nu plus 1 minus of n2 is equal nu minus 1, lowest frequency. So n1 minus n2 is equal to delta n. In the same way, nu plus 1 minus nu minus 1 is equal, so we can simplify, there is 2. So therefore the number of beats produced per second will be 2. So option B is the right answer.